Hey guys, it's good to be with you all again. We're going to be talking about 2-digit by 1-digit multiplication. Let's go ahead and look at our learning objective for the day. It is 3.4G, use strategies and algorithms, including the standard algorithm, to multiply a 2-digit number by a 1-digit number. Strategies may include mental math, partial product, and the commutative, associative, and distributive properties. And what we want to be able to do is I can use a variety of multiplication properties to multiply 2-digit by 1-digit factors, and I can use the standard algorithm to multiply 2-digit by 1-digit factors. Okay, got a video right here about 2-digit by 1-digit multiplication. Get ready and watch it.
How can you use breaking apart to multiply with greater numbers? Think about this question during the lesson. What have you learned about arrays like this one in the arrangement of the parking lot? Arrays are arranged in rows and columns. A parking lot has the same number of spaces in each row. How many spaces are in the lot? Which operation helps put together equal groups like these? Multiply to find the total for an array. Use an array to show 4 times 24. What blocks are used to show 4 times 24? To show 4 times 24, you make 4 rows of 2 10s and 4 1s each. Now find the product 4 times 24. Break apart 24 into 20 and 4. Think of 4 times 24 as 4 times 20 plus 4 times 4. How can you find the product of the tens part? The product of the tens part is 4 rows of 2 10s, which equals 8 10s or 80. Is this equation the same as 4 times 2? No. 4 times 2 equals 8, but 4 times 2 10s equals 80. Remember to say times 2 10s. The product of the tens part is 8 10s, or 80. How can you find the product for the ones part? The product of the ones part is represented by 4 rows of 4 ones, equaling 16 ones, or 16. Now add the partial products to find the total. What is the overall total? 80 and 16 are called partial products. What do you think partial means? 80 plus 16 equals 96. 80 and 16 are called partial products because they are parts of the product. The sum of the partial products is the product. 4 times 24 equals 96. There are 96 parking spaces in the lot. If the parking lot had a different number of rows, how would the partial products and the total number of parking spaces change? Think about this question as you do the activity that comes next.
Okay, let's go and look at this problem together. It says Janet earns $25 each night that she babysits her little sister. Janet babysat her little sister every Friday and Saturday night for 3 weeks. How much money did Jeanette make babysitting? Okay, so we'll go ahead and look at the problem. We know the first thing we want to do is we want to circle the important information. So that would be the $25. That's how much she earns each night. And she babysits her sister every Friday and Saturday night. And she did that for 3 weeks. Okay, so there's 3 numbers there. That's important. We'll talk about that when we start evaluating. Next thing I want to do is make sure I underline the question so I can understand what it's asking. And it says, how much money did Jeanette make babysitting. So we need to figure out how much money she made babysitting by the end of the problem. When we look at the problem, I can see basically we have the $25 and we have Friday and Saturday. So that's 2 nights. I'll write 2 right there. And we have 3 weeks. And I'm doing some evaluating right there. And it looks like I'm going to be multiplying in this problem to answer it. And I've got three numbers, which pretty much tells me it's a multi-step problem. And so I'm going to talk about we call it the associative property of multiplication. And basically that just means when we're dealing with a two-step problem, I can really do the steps in any order as long as they're both multiplication steps. Okay, so basically we'll do this one way. We'll go ahead and we'll say that we'll look at the $25, and she babysits on Friday and Saturday. So that'd be 25 times 2. So that would signify, okay, every week she would earn $50. Okay, and then I could go ahead and figure out, okay, well, how much money would she earn in 3 weeks? So I would multiply that by 3. And I know 50 times 3 is 150. So that means she would earn $150 in 3 weeks. So that would tell us that's how much money she earned babysitting her little sister on Friday and Saturday nights for 2 weeks. Okay, we could do it a different way though. We could go ahead and figure out how many days that's going to be altogether. So we could go ahead and say, well, for 3 weeks, and she does it 2 nights a week, that would mean that she babysits for 6 nights in those 3 weeks. And I could go ahead and multiply that by how much money she earns, which is $25. And I know 25 times 6, there's 4 25s and 100. So, and 2 more would be 50, so that's 150. And that's how much she earns babysitting. Or we'd even say we could skip, we go the $25 that she earns every night babysitting her sister. And we can say she's going to be babysitting for 3 weeks. So we could do 25 times 3. And we could say if she babysitted 1 night a week for 3 weeks, that would be $75. Okay, but she actually babysits twice a week. So basically all I have to do is 75 times 2, or double 75, which is 150. And that's all the different ways we could solve that problem. And that's kind of proving the associative property of multiplication, which when we're multiplying, we can multiply we can group them together anyway, and we can pretty much multiply in any order. We're always going to get the same answer. Okay, let's go ahead and look at this guided practice problem. It says, which is another way to find the product of 18 times 3? And we know product means to multiply, and it shows a multiplication problem there. So we'll go ahead and do a mental math way of solving that. I like this little trick here. So if I take half of 18 and I double 3, half of 18 is 9. And if I double 3, that's 6. That's the same thing as 9 times 6. And I can use my fingers to do 9 times 6. 1, 2, 3, 4, 5, 6. So I tuck in my 6th finger there. That would be 54. 54. So 18 times 3 would equal 54. So I'm going to write that right here, 54. 18 times 3 equals 54. So we're going to look at our answer choices now and see which answer choice equals 54. So answer choice A, what is the sum of 18 plus 18 plus 3? Okay, we'll check that out and see. I'm going to do 18 times 2, and then I'll add 3 to that. So 18 times 2, or I could go ahead and say 9 times 4 because I take half of 18, which is 9, and double 2 is 4. 9 times 4 is 36. And then I add 3 more to it. That would equal 39. So the sum of 18, and 3 is 39. What is the sum of 18 plus 18? Yep, that's correct. We already did that one. We said 18 plus 18 is 36. The next answer, answer choice C, the sum of 10 times 3 and 8 times 3. Okay, we'll see. I know 10 times 3 is 30, and 8 times 3 is 24, and 24 and 30 equals 54. That looks like, I'm going to put a question mark there, that looks like that may be my answer. And the last one, D, the sum of 8 times 3 and 10. Okay, we'll check that out. We already said 8 times 3 is 24. And we add 10 to that. That would equal 34. So it looks like we can eliminate answer choice A, B, and C because none of those answers equals 54. And we'll double check using the standard algorithm, make sure we didn't make a mistake on our mental math. So we'll do 18 times 3. Standard algorithm says I'd multiply 8 times 3, and 8 times 3 is 24. I like to circle that and put a little plus sign there so I don't forget. And then I'd multiply 3 times 1, and then 3 times 1 is 3, plus 2 would be 5, and that's 54. So 18 times 3 is 54, and the correct answer choice would be answer choice C. That'd be another way of doing it. And that would basically be the partial product method of solving that problem. Okay, let's look at this problem together. It says Skylar's uncle gave him 4 packages of baseball cards. There were 28 cards in each package. How many cards did Skylar's uncle give him? So let's go ahead and look at this. We're going to circle our important information. So there's 4 packages of baseball cards, and there are 28 cards in each package. I'm going to underline the question, and what we need to know is how many cards did Skylar's uncle give him? So by the end of this, we need to know how many cards he gave him. I'm going to box in some operational clues. I see right here, each package, it's kind of telling me it's equal groups. I'm going to do some evaluating right here. So we know it's equal groups. I got 4 packages and 28 cards. That doesn't sound like an addition subtraction problem. So we said it's equal groups. And when we're talking about equal groups, it's always a good idea to go ahead and talk about the get strategy. So do I know how many groups there are on this problem? Yep, that's correct. There are 4 groups, and the 4 groups are the packages. Four packages. Do I know how many are in each group? Yeah, right here it says there's 28 cards in each package. So that goes right along with my each. So that's, or I'm seeing 28 cards in each package. So there's 28, and that's cards. And do I know the total? No, we don't know what the total is. That's what we're trying to find out. So what operation am I going to use when I know the groups and how many are in each group? That's correct. That's a multiplication problem. So the multiplication problem we use to solve this is 28 times 4. So what is 28 times 4? Okay, let's check and see if that's correct. So we'll do 28 times 4. I'm going to use a partial product method to solve that this time. So what I'm going to do is I'm going to do the product of 8 and 4. And I know 8 times 4 is, if I double 8, that's 16. If I double 16, that's 32. So 8 times 4 is 32. I'm going to write the product of 8 times 4 there. And then I need to do the product of 20 times 4. And same thing, if I double 20, that's 40. And if I double 40, that'd be 80. So 20 times 4 is 80. Then all I got to do is add the two products together. That's 2, and 8 plus 3 is 11. So that means he got 112 cards. So the total would be 112, and that's cards that his uncle gave him. That would be answer choice B. Okay, which is not a way to find the product of 33 times 3. So first thing we'll do is go ahead and find out what is the product of 33 times 3. Okay, we'll check that using the standard algorithm. So that is 33 times 3. Using the standard algorithm, I'd multiply 3 times 3, and 3 times 3 is 9. And then I would multiply 3 times 30, and 3 times 30 is 90. So 33 times 3 is 99. We'll go ahead and check our answer choices and see which ones equal 99, and those will be the ways to do it. And there should be one way not to get 99. So answer choice A. Okay, the sum of 33 times 1 and 33 times 2. Okay, we'll check that and see if it's right. I know that 33 times 1 is 33. And 33 times 2, I'm just basically doubling 33, that'd be 66. And the sum of 33 and 66 is 99. Okay, and basically we can tell that's correct because I'm basically multiplying 3 times 1 and 3 times 2. That basically is the same thing as 33 times 3. Answer choice B, the difference of 33 and 3. Okay, let's check and see if that's right. 33 minus, the difference would be a subtraction problem. So if I take 3 away from 33, that would equal 30. So that looks like that may be my way not to get it because I did not get 99. But we'll go ahead and check the rest of the answer choices. What is the sum of 33 plus 33 plus 33? Yep, that is correct. It is 99 because I'm basically doing repeated addition with 33 3 times. And D, the product of 3 times 33. Yep, that's correct. That is 99 also. Basically just use the community property and we flip-flop the numbers around. Instead of doing 33 times 3, we did 3 times 33. And we know there's a community property of multiplication. So if we turn the numbers around, I'm still going to get the same answer. So A is a way to get it, C is a way to get it, and B is a way to do it, or D is a way to do it. B is not a way to get the product of 33 times 3. Okay, it's time again to complete your independent practice. You're going to complete the Schoology lesson after this video. I'll put a PDF in there so you can print it out, make it a little bit easier to work on. But take your time and do your very best. And if you have any questions, please email your teacher or send them a message on Schoology. And best of luck to you.